Great, Andre. Thank you so much. So Andre covered a lot of ground in whatever last 20, 25 minutes. And he provided a lot of excellent highlights of what's going on at ONF and the larger open networking community. So what I'm going to do with my colleagues, Saurav Das, he's our VP of Engineering, and Oz Sunay, he is my colleague at ONF, who is the Chief Architect for Mobility. So in next 30 minutes or so, what I'm going to do is to provide you state of ONF. So you guys are members of this community. Some of you are sponsors. You provide a lot of support to us. So I'm going to, give you an update on what we have been doing for last year, what are the highlights, and what you can look forward to. Some of this will essentially build on the highlights that Andre already provided. So you can think of it that I'm now taking you into a little more details about what's going on at ONF. Okay? So with that, let me get started. So I think before I get into the details of what we have been doing, I feel that I should tell you what our mission is. I know you have heard me say this multiple times, but please stay with me for another couple of minutes so I can remind you. So remember that our mission is to really help operators transform their networks and services and to bring them a lot more CapEx and OpEx efficiencies and help them deliver more innovative services on their network as a platform. Okay? And the way we accomplish that is by leveraging architectural innovations such as SDN, NFV, cloudification. So these are the architectural innovation, but then we also do that with disaggregation and open source. And yes, our focus is primarily at access and edge. Okay? But what is important to realize is sometimes ONF gets described as an SDN organization, sometimes it is described as an open source organization. What I want to communicate is in order to bring about the kind of transformation that we are all after, we have to think about disaggregation, white boxes, open source, SDN, NFV, cloudification all together. It's not that only one of them can deliver the kind of transformation we are looking for. Okay, so we bring in ONF all of this together and seek some solutions and platforms. Now, yes, open source plays a very important role in what we do and what we deliver. And so what has happened is that in the process, we have, you can call it invented or created a very unique open source model. Okay, and you can call it operator-led, curated open source model. And this is what we practice, and to some extent, Andre talked about it as well. So the first thing is that we are an operator-led organization, and as Andre mentioned, we have the 7 operators that are at the top of our partnership. They are on the board and all of that. And they are the people that build the largest networks and infrastructure. They are the people committed to this transformation, and they know what their priorities are. What is important, what are the first set of use cases they want to deploy, and all of that. And so that is the role they play. They come together, and almost everything that ONF does is essentially defined by or prioritized by these set of operators. Okay? And then we also have a very unique engineering team that is part of ONF. And thanks for all the kind comments that Andre said about ONF. But this is a team that has no legacy to protect. This is a team very passionate about this mission. So they are able to pursue the kinds of platforms and solutions that are disruptive without worrying about the legacy, and that is quite important to our mission. And of course, we have also brought together what you can call very well-aligned or kiritsu of supply chain partners that are also committed to disaggregation, open source, SDN, and NFV. And together, this is what our community represents. And together, we build these platforms and solutions. And that is a very unique model that we are practicing in the open source community. Okay? Now, without going into any more details, so these are the partners. This is our board. We have a very supply chain partners as well. And you will see there are very different type of supply chain partners that are really committed to this mission and vision. Of course, we have more operators that are our members, and then 70 other member companies, and 70 plus more collaborators as well. Okay? So now let me summarize the highlights very quickly. What are the important milestones that we are hitting this year and that we all can be happy about and proud of? So the first thing is that you will see that when we talk about access and edge, finally a number of pieces are coming together. And when you put these pieces together, you will see that finally our community has the pieces together that we can build next generation access and edge platforms and solution for the operators that are wanting to transform their network. Some of our platforms and solutions are starting to get into production networks, and that is something to feel really good about. Andre already mentioned about Trellis and ONOS, so that is the example. And then there are a few that are in the pipeline that are in the trial phases, and we hope that end of the year or by next year, these will be in production as well. And then again, this may seem like I'm kind of repeating some of the things Andre already highlighted, that we have very exciting forward-looking agenda as well. And that is the next-gen SDN, and then the convergence story that we are doing, that is how do we converge mobile and wireline together. Because once you have done disaggregation, once things are in software, you will find that convergence becomes much, much easier than it has been possible in the past. And we are undertaking some platforms to demonstrate how we can do that convergence. Okay? So when you look at the mobile access and edge, the kinds of things that come to mind is, the first thing is, do you have a networking substrate that connects everything together? And yes, with Trellis is the distributed leaf-spine fabric that does that. On the wireline side, then you want access and the core. So you can think of BNG as the core, and you will see that we have now platforms and solution for the wireline access as well as the BNG. Then on the mobile side, again, you need RAN and the mobile core. And again, we have platforms and solutions in this space. And all of that sits on top of the SDN control plane, that is the ONOS, and a whole bunch of white boxes that we are working with for servers, for switches, for OLTs, and for RAN as well. Okay, so that is how the picture comes together and how these pieces are coming together. Now I'm going to invite Saurav to come and talk about the wireline and the Trellis fabric part of it.
Thank you, Guru. So jumping right in, so Trellis, which Guru said is the network substrate on which all of our projects are built on top of, it's production ready. It's multi-purpose, and it's built on 3 core tenets, okay? And those being, well, first of all, it's SDN-based. So Trellis is a set of applications that run on top of an ONOS cluster, ONOS being our SDN controller. And then they talk using a variety of protocols down to the leaf-spine fabric, which itself is based on white boxes and merchant silicon. And Trellis is open source. So every single line of code that we write here at ONF is open source. And the primary use case of Trellis is that it's really optimized for the service provider access and edge. By that we mean that service providers have central offices or cable head ends, and there's a variety of different kinds of access for mobile, for residential, for enterprise that can hit Trellis leaves and then be routed to either compute nodes for NFV traffic, or some other traffic can be routed upstream to the service provider's core or metro network. So Trellis is optimized for these applications because when you think about it, there are many other fabric solutions in the networking industry. But Trellis deals with a lot of different kinds of traffic that comes. For example, from OLTs, you could get double VLAN tag traffic or PPPoE traffic. From R5s, you could get L2TP traffic. From base stations, you could get GTP encapsulated traffic. So Trellis has a number of features that deals with these different kinds of traffic that you don't normally find in enterprise data centers. Trellis also has a number of switches. It works with a number of different kinds of switches. Some of them you don't normally find in enterprise data centers, which have deeper buffers and bigger tables and lots of QoS capabilities. And finally, Trellis itself can be distributed. So you can imagine that your compute resources, your storage is all in the primary central office, and then your access nodes are actually connected to a secondary field office that is deeper and closer to the end user and subscriber. So Trellis from there backhauls the traffic onto the primary central office. So all of these make Trellis very optimized for service provider access and edge solutions. And we'll have a lot more to say about this in the keynotes on Friday. So I do encourage everyone to attend the Friday session. OK, so moving on, then I'd like to talk about some things that are built on top of it, right? Especially the wireless, the wireline side. And if you look at a traditional wireline access in a fiber to the home, fiber to the business, what we call a passive optical network, in the central office, you will typically find this OLT, or optical line terminal, which is the head-end box. And then it goes through a distribution network to the boxes that are in the homes, which are called ONUs or ONTs. And then the set-top boxes are behind that. So upstream from the OLTs, a set of OLTs connect to an Ethernet aggregation switch, and then onto a router that is known as a BNG, which does, it's a more specialized router that does per subscriber service management. So each of these boxes today are closed, proprietary, not externally programmable, a source of high CapEx and OpEx for operators. And so there is an opportunity to bring SDN, disaggregation, open source, all of the things that ONF stands for, to traditional wireline access. So we've done that. We have done that starting with the OLT. We have kept what you need to keep in hardware, but pizza-sized box hardware, the Mac and Phi, and then managed it outside the box using one of our projects called Volta, or virtual OLT, hardware abstraction. We've done the same thing with the Ethernet aggregation switch, which I just mentioned with Trellis. And so this all comes together in a pod, on a SEBA pod that looks like this. A set of OLTs, the pizza-sized box OLTs built on, these are white box OLTs built with merchant silicon, managed outside the box by Volta, and the SDN controller and a set of applications written on top of the SDN controller. Upstream from these OLTs, you have white box switches. And again, they're managed externally using Trellis applications running on top of ONOS. These switches then connect to a BNG, a traditional BNG that is outside of the SEBA pod. They also connect to servers, which host all of our software, the software stack that you see over here, plus a very important piece of our stack called the Network Edge Mediator that has three main functionalities. One, it does the FCAPS and monitoring that all service providers need for their equipment inside the pod. Two, it is a service orchestrator, so it manages every piece of hardware and software and their life cycles inside the pod. And it also, the third functionality is that it provides the northbound APIs with which a SEBA pod or multiple SEBA pods can be connected to an operator's backend OSS, BSS systems. Importantly, all of our software is containerized and with Docker containers managed using Kubernetes and installed using Helm charts. So to give you a very quick idea about the roadmap, we released SEBA last year. We are supporting the high-speed internet access service. We went one step beyond in the second release of SEBA, which brought in a very important feature that does QoS management for in passive optical networks, together with per subscriber bandwidth profiles. We will upgrade some of this software to a newer version, which supports more capabilities in a SEBA release that is coming out soon. But I'm more excited to talk about what is in SEBA 3.0 and beyond. So a lot of the community, and you'll hear about it if you attend the SEBA tracks in the afternoon and over the next couple of days, the entire community is working on the next version of Volta, and that is our primary focus these days. You'll also hear about some exciting work that we are doing on the side. It's experimental work right now about taking that BNG that we left outside the SEBA board, but bringing in that same white box and open source and bringing it inside the box, we call it an embedded BNG. And of course, like I've said before, SEBA has traditionally, so far, working with AT&T, but we're going to bring in Deutsche Telekom and Turk Telekom features. So all three operators are committed to taking SEBA to production next year and are working very hard with the community to accelerate SEBA and Volta to bring it to production readiness in order to be deployed next year. So we're very excited about that. So quickly, I just wanted to highlight some of the new work that is happening. I touched the OLT, and we made that, we made that with Volta. We did the Ethernet aggregation switch with Trellis, but we left the BNG alone. And there were good reasons to do that. There's a lot of functionality that goes inside this very specialized router, but we believe now that we can do the same thing to the BNG that we have done to the OLT and the aggregation switch, okay, using P4 and white boxes and applications written on top of ONOS. So this is what it will look like. In the aggregation switch, we're using another ONF project called Stratum. It supports next-gen SDN interfaces like P4 runtime, GNMI, and GNOI. And then the box itself, which is highly programmable silicon made with a P4 switch, which is another one of our projects at ONF. And then that BNG functionality will be implemented in the data plane inside the P4 switch and inside the OLT, but and using applications that run on top of ONOS or other control plane software that already pre-exists. So there's a functional distribution of the BNG functionality in multiple silicon inside the SEBA pod. So we have a very exciting demo. If you have the time, please do go and take a look at the demo about this new functionality. And so with that, I'd like to invite Oz, who's our Chief Architect of Mobility, to tell you about the mobile aspects. Please welcome Oz.
Thank you. All right, let me start with the RAN. So following the ORAN vision, the disaggregation of the RAN really is splitting the RAN software stack into three distinct components. And then subsequently actually invoking a user plane, control plane separation for the component that would be hosted at the edge cloud. One thing to pay attention here is that this stack really fundamentally conducts two distinct tasks. The first one is the packet and signal processing of the user and control data. And the second one is the radio resource management control of the RAN. So moving to a software-defined control of the RAN effectively enables the operators to programmatically and in a customized way conduct radio resource management using a logically centralized controller. And this controller has a much wider view of the wireless network state than any one base station alone. And to conduct this control, it needs to interface in the disaggregated case both with the DU and the CU. And the standardization of this interface is actually ongoing at ORAN Alliance. But the software-defined control of the RAN doesn't necessarily depend on disaggregation. So you can and you should be able to invoke the control using the same controller for a compliant all-in-one base station as well. So now, once deployed, this SD-RAN control becomes a very crucial component of the mobile network. So as such, high availability becomes a really important requirement to ask from such a controller. In addition, we are dealing with a mobile network. So that means users are on the move, and as such, we have to make sure that we have a federated RAN control across multiple edge clouds. So ONOS comes out of the box supporting these. And in addition, the modular structure of ONOS creates an environment where we can, without much difficulty, we can define and design RAN-optimized southbounds and northbounds. So this combined makes ONOS a very powerful baseline for an SD-RAN control. So when we actually go to the innards of this control, let's start from the southbound. The southbound interface actually allows the base stations regularly update the time-varying mobile network state to the controller. And in return, the controller uses this southbound to send commands for radio resource management. The controller itself clearly needs to keep a track of the mobile network state. And in addition, it needs to expose in an abstracted way this mobile network state to the RAN applications. These applications are going to be radio resource management applications or more advanced control applications that base on these radio resource management applications. And when you actually think of where things are going, these applications are increasingly going to be inference-driven. So as such, there's going to be machine learning components that run in non-real time elsewhere. So that means we need an interface so that that interaction is made possible. We have a demo on showcasing how ONOS actually can conduct an SD-RAN control. So please go see that. And a big shout out to the Sterlite team who actually worked very, very hard to make sure that you get to see a good demo. So next, let's talk about the mobile core. So ONF's disaggregated CUPS-compliant mobile core is OMEC. As Andre and Guru have mentioned, this has been, the seed code has been provided by Sprint and Intel. And now, as an ONF project, we have the entire ecosystem working on making this more and more production ready. So the first phase of that work is actually ongoing thanks to the efforts led by T-Mobile Poland and Sprint, because they have ambitions to take this to field trials. So as such, the gateways of OMEC are going through a hardening phase. And in addition to that, we are also adding new features, getting it more and more ready towards field trials. So we have, for example, lawful intercept integration and the latest 3GPP SX compliancy, et cetera, that are being integrated. When we focus on the MME, we are also, as the big ecosystem, going through a software re-architecture of the MME and also adding new features with a target of moving this into a form that is going to be field trial ready as well. And the software re-architecture is also going to help us with an easier migration to 5G core and a cloud-native architecture. And following all other ONF projects, the OMEC project has a CI/CD process in place as well. But there are specific mobile requirements that we had to integrate into the CI/CD process. One very important thing is every time there is actually a contribution or a bug fix, you have to make sure that the 3GPP compliancy is intact. So that has to become an automatic part of a CI/CD process. The second aspect is, as I mentioned, especially with the gateways, we are moving towards potentially production networks. That means these always have to be performant. So every time there is a new code, you have to stress test it. Stress testing it means that we have to have a very solid RAN emulation platform that we test this code against automatically every time there's a new contribution. So I mentioned the field trials. So T-Mobile Poland and Sprint are going to be the first two operators taking this to field trials. Both trials are expected to be within this calendar year. Specifically for T-Mobile Poland, this is going to be a trial for the use case of fixed mobile substitution. And for Sprint, this is going to be a local breakout setup. So next, I'd like to talk about the mobile edge cloud. So over the last number of months, we have been very busy trying to develop ONF's first ever official mobile edge cloud platform release. And I'm proud to say that our release is going to take place next Friday. And this release actually builds on the already hardened latest SEBA platform, and it uses that as its baseline. But there are additional features that we had to worry about, this being a mobile edge. One of these is the capability of supporting hybrid clouds. The reason for that is simple. If a mobile edge cloud is part of a mobile network, as such, you need to make sure that you have connectivity to the central cloud as well as the neighboring edge clouds. So in this platform, also, we have OMEC, a native component. But along with the hybrid cloud enablement, we have the capability to programmatically distribute OMEC across multiple clouds. The platform also comes with a sample end-user application, and that is a CDN allowing you to do multimedia streaming. And just like OMEC, this also has a distributed layout that you can enable in the platform. In addition to this, the platform also has a development arm, and that is entirely cloud-based. That does not require any hardware. And that development platform from the cloud enables you to look at OMEC or any other platform component with an integrated RAN emulation platform so that you can actually test new features or do bug fixes without actually needing to build the entire platform on-prem. So this is also another demo that I'm inviting you to go see. We have in our demonstration, actually we're using Santa Clara, this hotel, as the edge cloud, and our ONF office in Menlo Park is the remote cloud. And we have distributed OMEC across these, and we have the CDN also distributed across, and we have a commercially available small cell, a disaggregated small cell connected to this, and this small cell is also software-defined controllable. So we have an ONOS-based software-defined control that specifically allows you to do network slicing that includes the slicing of the RAN. So when we go under the hood of this platform, we see that it includes Kubernetes. And the first thing Kubernetes instantiates is NEM. Using Helm, you also automate in a customized way the build of this platform. So we have, in this specific case, a mobile edge cloud profile. But if you happen to actually add a second profile description as a Helm chart to this platform, like SEBA, for example, then you can have these two solutions share the same platform. So in addition to that, this profile automates first the ONOS with trellis applications for the leaf spine fabric control of the edge cloud, and then ONOS SD-RAN with RAN applications for the access control part of things, and then the containers of network functions for both RAN and core that you would like to install at the edge. In addition, all of the applications that you would like to have at the edge are instantiated here as well. There is also, along with hybrid cloud interfacing, there's a second interface here, which is the FCAPS capabilities. So using Prometheus and Grafana, as well as extensions to OMEC, now we have a monitoring and edge cloud state exposure that allows you to look at the usage of CPU and storage, as well as fabric traffic, as well as ingress and egress traffic on a container base, and mobile subscriber information. So the last thing that I would like to talk about is over the last number of years, we have been focusing as the MCore team on a number of very successful demonstrations. And there, our focus has been cutting-edge technology showcasing rather than creating a stable field trial-ready software. And this has changed over the last 6 months, thanks to a large extent to the OMEC project ratification by the ONF board and TLT. So now, with this platform that we are going to release next week, you see that the baseline is already a hardened platform thanks to SEBA. And on it, we have OMEC, which, thanks to field trials, is going through a hardening process as we speak. And the mobile subscriber state is an extension of OMEC, therefore it is going through hardening as well. And the SD-RAN story is built on ONOS, and you've already heard that ONOS is already part of production networks. And all of the additions are going through the same CI/CD process that enables a very rapid move towards field trial readiness. Thank you, and on to you, Guru.
Okay, so my takeaways are, we are making, thanks to you, we are making a lot of good progress. Our platforms are moving into production or in the pipeline to go into production. And you will see, I think the most important thing is the operator commitments and their excitement for what ONF does is greater than ever. And because of their commitment, the supply chain and our ecosystem is very healthy and is able to do the kinds of things that we are doing. Okay, so that is my kind of the last slide.